Alright, hello everyone, my name is Jumbo Sun, and today I will be presenting my project on building conversational AI models inspired by two distinct figures, Jesus Christ and Donald Trump. This project explores the implementation and challenges of training AI models to generate text that mimics the style of these two figures. So first, introduction. This project focuses on creating two separate conversational AI models, one trained on recorded words of Jesus Christ and the other on the publicly available tweets of Donald Trump. The objective is to generate text based on given prompts, simulating the style and content of these two figures, and to explore the challenges faced during the training. So now the problem statement. The problem is generating realistic and contextually relevant text using AI requires comprehensive training on diverse datasets. The challenges is to train models capable of generating coherent speech from two very distinct language sources. As you can see in the chart here, the style of speech is very different from both parties. So let me show the objectives now. So the key objectives of this project are as follows. First, to implement AI models capable of generating human-like text in the style of Jesus and Trump. Second, to evaluate these models in terms of text coherence, style preservation, and content handling. Finally, to identify potential areas of improvement and future developments. So the data sources I use for this project, the two databases were used. One consisting the records of words attributed to Jesus, and the other tweets from Donald Trump. These datasets were cleaned, pre-processed, and tokenized to create the input sequence necessary for training models. The Trump datasets, which is highly diverse language, propose particular challenge compared to the more uniform text of Jesus record servings. So for preprocessing the data involve removing URLs, special characters, and unnecessary symbols. We normalize the text by converting it to lowercase and eliminating any irrelevant content. Tokenization was then applied, where each character in the text was mapped to a unique index, allowing the model to process the text as numerical data. And now the model the models used for this project are based on the recurrent neural networks, which is also called RNNs, with specifically LSTM layers. These networks are suited for sequential data like text, as they can capture dependencies between characters in a sequence. So each model consists an embedding layer, followed by an LSTM layer, and finally a dense layer for generating predictions. This architecture was chosen due to its ability to handle the complexity of natural language generations. And both models were trained using the cleaned dataset with a focus on minimizing the loss functions through the Atom Optimizer. The training process involved feeding sequence of text into model and adjusting the weights to predict the next character in the sequence. Training was performed over several epochs, with each epoch representing a full pass through the dataset. So here are some examples of text generated by the models. In the first example, the Jesus ad start prompt in the beginning we gather here and generates a response that attempts to maintain a religious tone. And meanwhile, the Trump AI gives a similar prompt, generate text that is somewhat disjoint and includes nonsensical phrases. These examples demonstrate the challenge in maintaining the coherence over multiple turns. So to evaluate the models, we consider factors such as coherence, style preservation, and relevance. The Jesus model performed not so well in the text that aligned with the tone of the recorded words, and also struggled with multi-turn dialogues. And also for the Trump model, while it's being more diverse in the vocabulary. It faced similar problem with nonsensical output. So as you can see, here is the example conversation. They are going back and forth, which is very nonsensical language here. So to identify the problem, some key problems identified during the project include like the first, the lack of coherent and multi-turn dialogue, particularly in the Trump AI. Secondly, here we see its overfitting, which resulted in repetitive and nonsensical text generation. And finally, both models kind of struggled with context retention, which is a crucial aspect of the generating meaningful conversations. While the model shows some potential, they fail to consistently generate coherent text over multiple turns. The Trump AI in particular produced many sentences that were grammatically incorrect and nonsensical. This issue can be attributed to being overfitting, and on the smaller noisy datasets, the Jesus AI also struggled with long-term context, often failing to produce meaningful response after a few iterations. The primary reason for this problem was limited to the dataset size and the nature of the training size. Trump's tweets filled with informal language, slang, and interruptions did not always align with the expected style of coherent conversation. And meanwhile, the Jesus dataset was more predictable but lacked sufficient data to maintain meaningful dialogue across multiple turns. And to address the issue repetition here, future iterations of these models could be benefit from using transformer architectures, which are better at capturing long range dependencies and producing more coherent responses. Additionally, increasing the data size and diversity will help merit overfitting, and implementing techniques like attention mechanisms could improve context handling. And moving forward, we can address that while the project successfully demonstrate the ability to create models that can generate text in styles of Jesus and Trump, significant challenge remains, especially regarding multi-turn dialogue and context retention. So for future improvements, including the use of larger data sets and more complex models, and better training techniques will help overcome these challenges and lead to more coherent and meaningful AI generated text. So I'll add something more. So moving forward, we can address these issues by using more advanced model architectures, like researching deeper into ChatGPT like GPT-2 and GPT-3, which are better equipped with handle long-range dependencies in text. Additionally, expanding the training datasets to include more diverse and complete dialogues will improve the model's ability to generate meaningful conversations. All right, thank you for listening, and that'll be all.